Hi friends, welcome. This is the part 3 of our mechanical engineering competitive exams theoretical questions and answer series on strength of materials. So friends, let's begin. Friends, this is question number 101. The maximum shear stress is dash the algebraic difference of maximum and minimum normal stresses. Options are equal to 1/4, 1/2 and twice. So here friends, correct answer is option C, that is 1/2. Next is figure 2.40, that is this one. The Morse circle of stress for two unequal and like principal stresses sigma x and sigma y acting at a body across two mutually perpendicular planes. The normal stress on an oblique section making an angle theta with the minor principal plane is given by. Your options are OC, OP, OQ and option D is PQ. So here friends, correct answer is option C, that is OQ. Next is in figure, this figure friends, again the tangential stress is given by. Here friends, options are OC, OP, OQ and PQ. So here friends, correct answer is option D, that is PQ. Next is in this figure, again the resultant stress is given by. Here friends, these are the options and here correct answer is option B, that is OP. Next is question number 105. Again this figure friends, the radius of the Morse circle in this figure, this one, is equal to. Here options are sum of two principal stresses, difference of two principal stresses, half the sum of two principal stresses, half the difference of two principal stresses. So here friends, correct answer is option D, that is half the difference of two principal stresses. Next is again for this figure friends, question is the maximum shear stress in this figure is equal to dash of the Morse circle. Options are radius, diameter, circumference, area. So here friends, correct answer is option A, that is radius. Next is Morse circle is used to determine the stresses on an oblique section of a body subjected to direct tensile stress in one plane accompanied by a shear stress, direct tensile stress in two mutually perpendicular directions, direct tensile stress in two mutually perpendicular directions accompanied by a simple shear stress, and option D is all of the above. So here friends, correct answer is option D, that is all of the above. Next is when a body is subjected to a direct tensile stress sigma x and sigma y in two mutually perpendicular directions accompanied by a simple shear stress tau xy, then in Morse circle method the circle radius is taken as. Here friends, these are the options and your correct answer is option C, that is 1 upon 2 into under root of sigma x minus sigma y the whole square plus 4 tau xy square. Next is in Morse circle, the center of circle from y-axis is taken as. Here friends, these are the options and here correct answer is option B, that is sigma x plus sigma y upon 2. Next is question number 110. Here the extremities of any diameter on Morse circle represent. Here friends, these are the options and here correct answer is option B, that is the extremities of any diameter on Morse circle represent normal stresses on planes at 45 degree. Now next is here the maximum shear stress is equal to the radius of Morse circle. Is it correct or incorrect? So here it is correct. So option A is the correct answer. Next is the energy stored in a body when strained within elastic limit is known as. Here friends, options are resilience, proof resilience, strain energy or impact energy. So here friends, correct answer is option C, that is strain energy. Next is the total strain energy stored in a body is termed as. Here friends, these are the options and your correct answer is option A, that is resilience. The total strain energy stored in a body is termed as resilience. Next is the proof resilience is the maximum strain energy which can be stored in a body. Yes or no? So here answer A is the correct answer. That is yes, it is true. The proof resilience per unit volume of a material is known as modulus of resilience. Is it true or false? So it is here true. Question 116. Strain energy is the. Here, friends, correct answer is option A. That is, strain energy is the energy stored in a body when strained within elastic limit. Next is the strain energy stored in a body when suddenly loaded is dash the strain energy stored when same load is applied gradually. Options are equal to one half, twice, or four times. So here, friends, correct answer is option D, that is four times. Next is resilience is the. Options are energy stored in a body when strained within elastic limit, energy stored in a body when strained up to the breaking point of breaking of the specimen, maximum strain energy which can be stored in a body, and option D is none of the above. So here, friends, correct answer is option D, that is none of the above. And next is the total strain energy stored in a body is called proof resilience. Agree or disagree? So it is disagree, friends. Total strain energy stored in a body is called resilience. Okay. Next is modulus of resilience is the proof resilience per unit volume of a material. Is it correct or incorrect? So it is correct. Next is the strain energy stored in a body when the load is gradually applied is. Here, friends, these are the options where sigma is equal to stress in the material of the body. V is the volume of the body. E is the modulus of elasticity of the material. So here, friends, correct answer is option D. That is sigma square V upon 2E. The stress induced in a body when suddenly loaded is dash the stress induced when the same load is applied gradually, equal to one half, twice, four times. Here, friends, correct answer is option C, that is twice. Next is the strain energy stored in a spring when subjected to maximum load without suffering permanent distortion is known as. Options are impact energy, proof resilience, proof stress, modulus of resilience. Here, correct answer is option B, that is proof resilience. Next is the capacity of a strained body for doing work on the removal of the straining force is called. Options are strain energy, resilience, proof resilience, impact energy. Here, correct answer is option B, that is resilience. Next is question 125. Which of the following statement is correct? Options are the energy stored in a body when strained within elastic limit is known as strain energy. The maximum strain energy which can be stored in a body is termed as proof resilience. The proof resilience per unit volume of a material is known as modulus of resilience. Option D is all of the above. So here, friends, correct answer is option D, that is all of the above. Next is the strain energy stored in a body due to shear stress is. Here, friends, these are the options where tau is equal to shear stress, C is equal to shear modulus, V is the volume of the body. Here, friends, correct answer is option C, that is tau square upon 2C into V. Next is question 127. A beam which is fixed at one end and free at the other end is called. Here, friends, these are the options, and here correct answer is option D, that is cantilever beam. Cantilever. Okay. Next is a beam supported at its both ends is not a simply supported beam. Is it true or false? So here, friends, it is false. A beam extending beyond the supports is called. Options are simply supported beam, fixed beam, overhanging beam, cantilever beam. Here, friends, correct answer is option C, that is overhanging beam. Okay. Next is a beam encastered at both the ends is called. Here, friends, these are the options, and here correct answer is option B, that is fixed beam. Next is a beam supported on more than two supports is called. Here friends, these are the options, and here correct answer is option D, that is continuous beam. Cantilever beam is one which is, here friends, these are the options, and here correct answer is B, fixed at one end and free at the other end. A simply supported beam is one which is supported on more than two supports. Is it true or false? So here friends, option B is the correct answer, that is it is false. Next is an overhanging beam must overhang on both the sides. Is it right or wrong? So here friends, correct answer is option A, that is it is right. An overhanging beam must be overhang on both the sides. So it is right here. Next is a fixed beam is one which is fixed at a dash of its ends. Here friends, options are one or both. Here correct answer is option B, that is both. Next is a continuous beam is one which is, here friends, these are the options, and here correct answer is option C, supported on more than two supports. A concentrated load is one which is, here friends, these are the options, and here correct answer is option A, that is acts at a point on a beam. A concentrated load is one which acts at a point on a beam. Okay. Next is a load which acts at a point on a beam is not called uniformly distributed load. Agree or disagree? So here friends, option A is the correct answer, that is agree. Next is a uniformly distributed load may be assumed to behave like a point load at the center of gravity of the load for all sorts of calculation. Is it right or wrong? So here friends, option A is the correct answer, that is it is right. A load which is spread over a beam in such a manner that it varies uniformly over the whole length of a beam is called uniformly dash load. Here options are distributed or varying. Here friends, correct answer is option B, that is uniformly varying load. The shear force at a point on a beam is the algebraic dash of all the forces on either side of the point, sum or difference. Here correct answer is option A, that is sum. The bending moment at a point on a beam is the algebraic dash of all the moments on either side of the point. Options are sum or difference. Here correct answer is option A, that is sum. Next is the bending moment on a section is maximum where shear force is, options are minimum, maximum, changing sign, 0. So here correct answer is option C, that is changing sign. The bending moment on a section is maximum where shear force is changing sign. Next is the shear force at a certain point on a beam changes a sign from positive value to negative value or vice versa. The bending moment at that point will be 0. Here options are true or false. So here friends, it is false. When a load on the free end of a cantilever beam is increased, failure will occur. Here friends, these are the options, and here correct answer is option B, at the fixed end. Next is the bending moment at the free end of a cantilever beam is 0, minimum, maximum. Here correct answer is 0. Next is here, this question is for this figure. Okay, this question. Now a cantilever beam of length L and carrying a point load W at the free end is shown in figure. Which of the following is correct? Here friends, this is the figure. Okay, this one, this is the figure here, as you can see, and here these are the options, and here correct answer is option B, that is A is the shear force diagram and C is the bending moment diagram. Okay, now next is When a cantilever beam is loaded with concentrated loads, the bending moment diagram will be a. Here, friends, these are the options, and here correct answer is option C, that is inclined straight line. Next is here the bending moment diagram for a cantilever beam loaded with uniformly distributed load will be a parabolic curve. Correct or incorrect? Here, correct answer is correct. That is A. Next is the maximum bending moment on a cantilever beam as shown in figure. This figure again, friends, lies at here, friends. This is the figure. Okay, and here these are the options, and here correct answer is option B, that is the fixed end. Friends, we have completed here part 3 of our mechanical engineering competitive exams theoretical questions and answer series on strength of materials. Thank you friends for watching this video. Like, share and comment for this video and subscribe my channel. Thank you.